students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as Interference of Light. Take down a sum please. In biprism experiment, the distance between the second and the 10th dark band, on the same side is 0.12 centimeters. The distance between the slit and the biprism is 20 centimeters, and between the biprism and the eyepiece, the distance between the slit and the biprism is 20 centimeters, and between the biprism and the eyepiece is 80 centimeters. If the slit images in two positions are 4.5 and 2 millimeters apart, find the wavelength of light used. Now guys, for dark, first of all I can find out the distance between the two slits. Distance between the two slits is square root of d1 into d2, right? Now for dark band I can say xn is n minus 1 by 2 lambda d by d, right? Now the distance between the 10th dark band and the second dark band on the same side is going to be 10 minus 1 by 2 lambda d by d minus 2 minus 1 by 2 lambda d by d. This is given to you as 0.12 into 10 raised to minus 2 meters. This is 9.5 minus 1.5, 7. No, 8 lambda d by d. You have the values of d and d. You can find the value of lambda. When you solve this, you should get the answer for lambda to be 4,500 Armstrong unit. Next, take down next sum please. In biprism experiment, the distance between the 4th and the 13th bright band, is measured when light of 6,000 Armstrong unit is used. When light of 6,000 Armstrong unit is used. On replacing the source of light, it is found on replacing the source of light, it is found that the distance between the fifth and the 15th bright band, the distance between the 5th and the 15th bright band is the same as the distance measured before. Is the same as the distance measured before. What is the wavelength used? What is the wavelength used? Now, they give you that the distance between the 5th and the 15th bright band is the same as the distance between the 4th and the 13th bright band. Now, for bright band, we know that xn is equal to n lambda d by d. Therefore, this is going to be 15 lambda d by d minus, we call this as lambda 2, minus 5 lambda 2 d by d is equal to 13 lambda 1 d by d, because remember the wavelength of light had been changed, minus 4 lambda d by d. So in which case you will get 10 lambda d by d is equal to 9 lambda d by d. D and D gets cancelled. You already know the value of lambda 1. You should be able to get the value of lambda 2. When you solve this, you will get this answer as 5400 Armstrong unit. Next, in biprism experiment, slit is illuminated by red light of wavelength 6400 Armstrong unit. Red light of wavelength 6400 Armstrong unit. And the cross wire is adjusted to the third bright band. The red light is now replaced by blue light. The red light is now replaced by blue light, and the cross wire lies on the fourth bright band. The cross wire lies on the fourth bright band. Find the wavelength. Find the wavelength of blue light. Find the wavelength of blue light. Find the wavelength of blue light. Now see guys, when I was using red light, the cross wire was on third bright band. Cross wire, this, when you see through a scope to pinpoint, this is called as a cross wire, the plus sign that you see. Okay. Now the third bright band for red, now instead of red, if I use blue light, the same thing is measured by the fourth bright band of blue. That means the third bright band of red corresponds to the fourth bright band of blue, right? But for bright band we know that xn is equal to n lambda d by d. That means I can say 3 lambda red d by d is equal to 4 lambda blue d by d. D and D gets cancelled, so you will get thrice lambda r is 4 lambda b. Substitute the values and you should get the answer. The answer for this should be 4800 Armstrong unit. Answer is 4800 Armstrong unit. Next, in biprism experiment, the eyepiece is kept at a distance of 1 meter. In biprism experiment, the eyepiece is kept at a distance of 1 meter and the bandwidth is measured. Another source is used and the same bandwidth was obtained when the eyepiece was at a distance of 80 centimeters. When the eyepiece was at a distance of 80 centimeters. Calculate the ratio of the wavelength. Calculate the ratio of the wavelength. Now see, they are saying that the fringe width remains the same in both the cases. That means fringe width in the first case is the same as fringe width in the second case, but fringe width is nothing but lambda d by d. So lambda 1 d by d is going to be lambda 2 d by d. They haven't specified anything about the distance between the two slits, so we can safely assume that the distance between the two slits is going to be the same. D and D gets cancelled, so I'm getting lambda 1 upon lambda 2 is d2 upon d1, and that's exactly what they had asked you to find out. The answer for this sum should be 4 upon 5. 4 is to 5. Right? Take our next sum, please. The distance between two consecutive bright bands. The distance between the two consecutive bright bands is 0.32 millimeters. Is 0.32 millimeters. When red light of wavelength 6400 Armstrong units is used. When red light of wavelength 6400 Armstrong unit is used. By how much will the distance change if blue light of 4800 Armstrong unit is used? If blue light of 4800 Armstrong unit is used. Now, guys, let's see this. We know that fringe width is nothing but lambda d by d. Therefore, I can say fringe width for red light is going to be lambda r d by d. Therefore, I could say that fringe width for red light upon wavelength of red light is d by d. Similarly, I can say that fringe width for blue light is lambda for blue light into d by d. But d by d we have already calculated as xr upon lambda r. Therefore, I can say that fringe width of blue light is lambda b xr upon lambda r. xr upon lambda r I know, lambda b I know. I should be able to get the fringe width of blue light. What have they asked me to find out? They've asked me to find out the change in fringe width. The change in fringe width is going to be modulus of xr minus xb. That will tell you how much is the fringe width going to change by. Right? Take our next sum. The answer for this sum should be 0.08 millimeters. Next, take our next sum, please. In biprism experiment, light of wavelength 6500 Armstrong units is used. Light of wavelength 6500 Armstrong unit is used. This is now replaced. This is now replaced by a light. This is now replaced by a light of 5500 Armstrong units. This is now replaced by a light of 5500 Armstrong units. Find the change in fringe width. Find the change in fringe width if the screen is at a distance of 1 meter. If the screen is at a distance of 1 meter from the source, which are 1 millimeter apart, which are 1 millimeter apart. Now we know that fringe width is nothing but lambda d by d. Now as lambda 1 is greater than lambda 2, we know that fringe width is directly proportional to lambda. Therefore I can say x1 will be greater than x2. They've asked me change in fringe width. Change in fringe width is going to be x1 minus x2. That is going to be lambda 1 d by d minus lambda 2 d by d. You have all the values. You should be able to calculate the change in fringe width. The answer for this sum should be 0.1 millimeters. Next, take our next sum please. In biprism experiment, slit is illuminated by a wavelength. Slit is illuminated by a wavelength. Slit is illuminated by a wavelength of 5890 Armstrong units. The distance between the slit and the eyepiece, is 80 centimeters. The distance between the slit and the eyepiece is 80 centimeters. Virtual images of the slit are 0.2 centimeters apart. Find the change in the fringe width. Find the change in the fringe width if the eyepiece moves 20 centimeters away from the slit. If the eyepiece moves 20 centimeters away from the slit. If the eyepiece moves 20 centimeters away from the slit. Now guys, the eyepiece was already at a distance of 80 centimeters from the slit. If it is moving another 20 centimeters away, then it will be at 100 centimeters from the slit, right? Now we know that guys, fringe width is lambda d by d. From this we understand that fringe width is directly proportional to the distance of the eyepiece at the slit. Now as D2 is greater than D1, therefore I can say X2 will be greater than X1. Therefore the change in fringe width, they have asked you to find out the change in fringe width. Therefore I can say that change in fringe width here will be X2 minus X1 will be lambda d by d minus lambda 1 d by d. Right? You have, no, lambda is same, it's d that is changing. So lambda d2 by d upon lambda d1 by d. Lambda and d is given to you, you should be able to calculate the change in fringe width. The answer for this sum should be, answer is 0.0589 millimeters. Next, take our next sum please. In biprism experiment, fringe width is 0.4 millimeters. Fringe width is 0.4 millimeters when the eyepiece is at a distance of 1 meter. Find the change in fringe width. Find the change in fringe width if the eyepiece is moved. Find the change in fringe width if the eyepiece is moved through a distance of 25 centimeters towards the biprism. 25 centimeters towards the biprism. Now guys, it was at a distance of 100 centimeters from the biprism. It is going to move 25 centimeters towards. So my new distance is going to be 75 centimeters. That is nothing but 0.75 into 10 raised to minus 2 meters. Okay. Now fringe width we know is nothing but lambda d by d. So this is lambda d1 by d. Similarly, I can fringe width is lambda d2 by d.
So that should be 75 into 10 raised to minus 2.
Yeah, that should be 75 into 10 raised to minus 2. Right? Now divide the two equations. So I get x1 upon x2 is going to be nothing but d1 upon d2. Substitute and you will get the change. You will get the new fringe width. But they have asked you the change in fringe width. Now as d1 is greater than d2, therefore x1 will be greater than x2, therefore change in fringe width is going to be x1 minus x2, right? Substitute and you should get the answer. The answer for this should be the change in fringe width is 0.1 millimeter. Right, take down next one please. In biprism experiment, light of wavelength 5200 Armstrong unit is used. Light of wavelength 5200 Armstrong units is used. The fringe width changes by 1.3 millimeters. The fringe width changes by 1.3 millimeters. The fringe width changes by 1.3 millimeters when the screen is brought towards the biprism. When the screen is brought towards the biprism by 50 centimeters. Find the distance between the virtual images of the slit. Find the distance between the virtual images of the slit. Now I can say x1 is going to be nothing but lambda d by d. Similarly, x2 is going to be lambda d2 by d. Therefore, I can say x1 minus x2 is going to be lambda d1 by d minus lambda d2 by d. So x1 minus x2 is 1.3 into 10 raised to minus 3 is lambda by d common, d1 minus d2. Now you should be able to solve lambda, you know, the distance between the slits, that is the small d is the only value that you don't know. You should be able to get this. You will get d is lambda, d1 minus d2 is 50 into 10 raised to minus 2 upon 1.3 into 10 raised to minus 3. Substitute the value of lambda, you should get the value of d. You will get the value of d is going to be 0.2 millimeter. Next, take down next one please. A certain fringe width is observed. A certain fringe width is observed. A certain fringe width is observed when green light of wavelength, when green light of wavelength 5350 Armstrong units is used. Where the distance between the slit and the screen, the distance between the slit and the screen is 1.28 meters. The distance between the slit and the screen is 1.28 meters. What should be the distance between the slit and the screen if red light of wavelength 6400 Armstrong units is used? To get the same fringe width. To get the same fringe width. To get the same fringe width. Now we know that fringe width is lambda d by d, right? Therefore I can say that. Now they've also given you that the fringe width does not change. That means they've given you that the fringe width of green light is equal to the fringe width of red light. That means lambda green, distance of green upon d is lambda red, distance of red upon d. Since they haven't said anything regarding the distance between the slits, we can assume them to be the same. So d and d would get cancelled. So you will get lambda g dg is lambda r dr. Right? You have to find out distance for red source. So dr is going to be lambda g dg upon lambda r. Substitute the values, you should get this answer. The answer for this should be 1.07 meters. Next, take on next one please. Two straight narrow parallel slits. Two straight narrow parallel slits are separated by 3 millimeters and illuminated by a light of 2 5,460 Armstrong units. If the distance between the slit and the screen, if the distance between the slit and the screen, if the distance between the slit and the screen is 60 centimeters, find the change in the fringe width. Find the change in the fringe width if the distance between the slit is if the distance between the slit is, first part of the question, if the distance between the slit is increased by 1 millimeter, is increased by 1 millimeter. Second part of the question, is decreased by 1 millimeter. First, let's get the original fringe width. Fringe width is nothing but lambda d by d. Right? I know lambda, d and d. Now, they have said that the distance between the slit increases by 1 millimeter. It was already 3 millimeters. If it increases by 1 millimeter, it becomes 4 millimeter. So my new fringe width is going to be lambda d by d1. Similarly, the next fringe width is going to be lambda d by d2. Now, I can say in the first part of the question, the change in fringe width when it increases by 1 millimeter is absolute value of x minus x1, and second case, the change in fringe width is modulus of x minus x2, right? So I'll come to know in both the cases what is the change in the fringe width. Fine, do we get this? The answer for this sum should be the answer is 2.73 into 10 raised to minus 5. That's for the first one, meters. And for the second part of the question, the answer should be 5.46 into 10 raised to minus 5 meters. Next, take our next one, please. In biprism experiment, the distance between the source, the distance between the two sources is 0.5 millimeters. The distance between the two sources is 0.5 millimeters. And between the slit and the eyepiece, is 1.2 meters. The slit is illuminated. By red light of 6,550 Armstrong unit. The slit is illuminated by red light of 6,550 Armstrong unit. If the red light is replaced by green light, of 5,240 Armstrong units, it is found that the nth red bright band, it is found that the nth red bright band coincides with the n plus 1 green bright band. Calculate the distance of this bright band. Calculate the distance. Calculate the distance of this bright band.
So here it doesn't matter whether it's on the same side or the opposite side.
They haven't specified anything. They said that I'm just considering, see, this is the central bright band. I get a red color here, right? If I'm keeping a red bulb, this is my distance of the bright band from the central band, right? If I keep a green, whether it is on the same side or other side, distance is always going to be the same. The problem is when you want to find out the distance between two bright bands, here I'm changing the color, so it doesn't make a difference, right? Okay, let's move on. Now, for bright band, we know that xn is equal to n lambda d by d, right? So in that case, they have given me that but xn red bright is equal to xn plus 1 green bright. So this is going to be n lambda r d by d is going to be n plus 1 lambda g d by d, right? I'm just using the bright band formula, right? In which case when I solve this, d and d gets cancelled, so you will get n upon n plus 1 is lambda g by lambda r. When you solve this, you will get the value of n, because n is the only unknown in this equation. Once you have n, what have they asked you to find out? They have asked you to find out the distance of the bright band from the central bright band. That means they have asked you to find out the distance of the red bright band. Therefore, distance of red bright band is going to be xn, which is going to be n lambda r d by d. Once you have the value of n, lambda r, d and d you have, you should be able to get the answer. Guys, in this sum, the answer for n that you should get is 5. I don't have the other answer that you can calculate now. Take our next sum, please. In biprism experiment, the distance between the first and the 11th bright fringe, the distance between the first and the 11th bright fringe formed by a light of wavelength lambda is 1.8 into 10 raised to minus 3 meters. Is formed by a light of wavelength lambda. Formed by a light of wavelength lambda is 1.8 into 10 raised to minus 3 meters. If the light is replaced by a wavelength, of lambda by 2, find the distance between the first and the 16th bright fringe. Find the distance between the first and the 16th bright fringe. Find the distance between the first and the 16th bright fringe. Find the distance between the first and the 16th bright fringe. Now, for bright band, we know that xn is equal to n lambda d by d. Therefore, I can say that x11b minus x1b will be 11 lambda 1 d by d minus 1 lambda 1 d by d, which is going to be 10 lambda d by d. That means I can say that 1.8 into 10 raised to minus 3 is equal to 10 lambda d by d, right? Take the 10 on the other side. So I can therefore say that 1.8 into 10 raised to minus 4 is equal to lambda d by d. Now they are saying that you have to find out the distance between the first and the 16th bright fringe when the light is replaced by when the light is replaced by a light of wavelength lambda by 2. I want to find out the distance between the 16th and the first bright fringe when the light is replaced. Okay, so in this case this is going to be 16. Wavelength of light is x2 d by d minus 1 lambda 2 d by d. So that is 15 lambda 2 d by d, right? But lambda 2 is nothing but lambda divided by 2. So this is 15 into lambda divided by 2 d by d. So this is 15 upon 2 lambda d by d. But we have already found out the value of lambda d by d. So this is 15 upon 2 into 1.8 into 10 raised to minus 4. Right? Now you can do your calculation and get your answer. You should get the answer for this as 1.35 into 10 raised to minus 3. Right? Right. We'll stop this here for the day. Thank you very much.